In this video, we're going to be taking a look at how to find the product of prime factors and also how to answer questions like these. Essentially, prime factors are just prime numbers that can be multiplied by other numbers to make a given number, which is done in the method of a factor tree, like the one shown here. In this question here, we're asked to give 36 as a product of its prime factors. We firstly need to list a few prime numbers, preferably 6 or 7 of them, so that we know what we're working with. 2, 3, 5, 7, 11, 13, and 17 for our 7 prime numbers here for this question. Also, I'd just like to say that when you get this type of question, it's best to start with 2. As dividing the number that we've been asked to give as a product of its prime factors, being 36 in this instance, would be a lot easier if we just divided it by 2, and so the process in answering the question in the next step would be a lot easier, especially with bigger numbers, which you may be asked to answer in the exam. Now that we've got our number 36, we can proceed to go ahead and multiply 2 by another number to make 36. Or we can do 36 divided by 2. Either way, it would work. We can now expand our factor tree by repeating this process with our new number, 18. 18 divided by 2, which is 9. Then 9 divided by 2. But that wouldn't work. So we would do 9 divided by any of the numbers in the prime numbers list here that are divisible. In this instance, 3. We just do 9 divided by 3. Now that we've reached the end of our factor tree, we wouldn't go any further than this, as 3 divided by 3 is 1, and remember that 1 is not a prime number. Now if we were to move up the factor tree, you can see that 3 times 3 makes 9, 2 times 9 makes 18, and 2 times 18 makes 36. This would be the same process in other factor trees, which is exactly what's defined by product, meaning to multiply, as 2 times 18 makes 36, 2 times 9 makes 18, and 3 times 3 makes 9. The next step to do now is to list our prime factors. It wouldn't be 18 or 19 as they aren't prime numbers. The rule of thumb is to circle the numbers that are only prime, which we see here to be 2, 2, 3, and 3, which becomes 2 times 2 times 3 times 3. As remember, we are giving 36 as a product of its prime factors, where product means to multiply. As we can see here, we have to give 120 as a product of its prime factors, where we first list some prime numbers to work with, like this, then put 120 at the top of our tree, which we would then split into 2 parts. Let's say we used 2. It would be 2 times 60, or if we use 3, it would be 3 times 40, and so on. Since this is for demonstration purposes, let's use 2. Then for 60, it's 2 times 30. Then for 30, it's 2 times 15. Then for 15, it's 3 times 5. Next, we circle our prime factors, being 2 times 2 times 2 times 3 times 5, which is 120. We're not just finished yet, so we've been asked to give our answer in index form, where we express our prime factors as 2 to the power of 3 times 3 times 5, as there are 3 2's, which is endorsed as 2 to the power of 3, and then 3 times 5 stay the same. Let's say we had some random numbers, which are 3 times 3 times 3 times 3 times 7 times 7 times 2, which we would then rephrase this as 3 to the power of 4 times 7 to the power of 2 times 2, which would be considered as index form or index notation. I'd also like to point out that you cannot have any decimals for when it comes to factor trees, thus being the same rule for index form.